Hello, folks. We are live streaming onto the Code Borging what's it called? A YouTube channel. So I'd appreciate if people could watch it there. Also, just mute the tab so that YouTube actually knows there's people who care about this, hopefully. Otherwise, only Zoom will know that. And ideally subscribe. But everybody, you have don't if you don't want to be on YouTube, um, change your name, don't turn on your video, ask all your questions in chat. Now I need to remind my friend that he agreed to come. Time to come. Because he is um a really good KDB expert and can make lots of nice suggestions about how to make this a better tool. Um, Good. Oh, Mike says he's on. I wonder. Oh, there he is. Yes, Michael is on. Yay. Thanks so much. Um, okay. So the basic idea here is, oh yeah, um let me see here what um so yes, so here's a nice story. Um I was working with an intern. Let me see, how is this showing up in okay, yes. So I was working with an intern and it came up that in KDB, um, explicitly iterating is kind of like, for many reasons, not looked too fondly at. In fact, if you don't mind talking a little bit about this, I mean, partly you're losing a lot of the power of the language and the implementation as an interpreter. But you get into similar problems with recursion. Um, um, Michael, do you want to jump in and say a few words here?
Yeah, every time you run a loop, the interpreter's got to evaluate the statement, so that adds overhead. So we prefer to just do things with vectors.
So yeah, so the amazing performance and stuff is done by calling what I like to think of as Arthur's code. Although by now there's a few other people who've had a hand in there. It's not all Arthur, but was originally Arthur. So this experiment was inspired by my doing a little bit of teaching and saying, huh, what about if you have a really recursive data structure? What could you do so that you could like do the equivalent of recursively descending through a data structure, um, even though you were really doing it iteratively. And then once you have, so here in this example, um, I created this this table. Oh yeah, for people who don't know KDB, like a lot of the time we do things with tables that can be either they can be in memory, they can be on disk in a number of different formats, including memory mapped. Sometimes I have to ask people who've been involved with the design of other programming languages like Kent here, who's on this. Why is memory mapping not something that other high-level languages just um anyway, that's definitely a tangent, but Kent, remind me to ask you about this because it's like so core, I think, to how KDB is able to do all this real-time data warehousing stuff, having very convenient to memory map data structures. Like, do people, when they design other programming languages, like various dialects of Lisp, do they even consider they might want to have that as a low-level thing?
It's
Anyway, so,
probably not portable.
oh, say again, Kent?
It's probably just a portability issue. When you rely on very low level cool things like that, you almost always run into some sort of portability problem. Um,
Huh.
but yeah,
So you're saying it's going to make it miserable for implementers to find a way to implement these things portably.
yeah, I mean, especially across operating systems. But yeah,
Yeah, it'd be interesting to talk to um the people who developed this system. Like, how did they deal with that? I guess they only really cared about Linux, Windows, and more recently Mac, I guess. Anyway, okay, so the idea here was if you assume that your tree data structure is going to be represented in this way, where there's some ID and then there's some parent ID, we can write um, uh, some uh, some KDB code that allows you to walk down the hierarchy and then end up with the numbers, the IDs for those columns, for those rows, and then once you have those, you can apply. It's very easy, in Q, to, you know, total up prices or costs or whatever. Although that's very easy to do. So I thought this was a really nice example. Oh, and then um, I also wrote a version that is recursive. And yes, spoiler alert, the recursive version is considerably slower than the what I take to be. Although it'll be interesting, I wouldn't be surprised if I get an email from Michael with a way better version than this, like in a few hours or a day. Um, so it'll be interesting if I inspire Michael to do that. Oh, I should say the code is out on the code borging GitHub repository under bdd.q or bddq, something like that. You'll see it. I'll uh, I'll post it on the YouTube. So the idea here is it would be nice to be able to document your test cases um, in a way potentially right in with the code, or at least some subset of the test cases. And then the idea is to have at least two nice things you can do with them. One is if you happen to write sum all of this stuff first, and you're using, let's say, well, any of these LLMs, but in particular, what I currently have turned on is Copilot. When I load this file, it will generate a dummy file that has all of this written out as a kind of comment designed to be read by an LLM. So let me load a recursion.q that's supposed to be avoiding recursion. And now when I say run what te run tests, run tests, um, it says all the tests passed. Oh yeah, so just to make this more interesting, let's have it fail a test. Let's put a 0 here. So um what we so we get here is that this particular test now failed, and when it failed. And one of the things, of course, we're in a position to do Oh, someone is not muted. Mute. Oh, maybe everybody's muted now. Cool. Now, one idea we've just started playing with is if I know that I've got something on the left side of the tilde. I mean, not that they're in a test case, they're necessarily. Oh, by the way, I should explain. I I think the dominant unit testing framework used by KDBQ programmers is K4 unit, spelled with a 4. And that's the one I'm using here. In fact, what I'm really doing is generating this descend on .csv file and then just calling. So that's the format of this. Is anybody having trouble reading this? Should I try to make things bigger or smaller? What makes sense? Readable? I I guess it's readable. Not hearing anybody complain. So this is so anyway, what we were saying is at least in my test cases, there's always kind of a tilde that is an equals, an equality test saying, hey, here's what I actually computed and here's what I expected. So the idea that I'm exploring right now, and I'd love to get people's thoughts about it. Let's see, I have um, is to do an automatic analysis of this to say, oh, look, apparently I was expecting something of length 17, but I only got something of length 16. It's like, why do I have to do the thinking about the failed test case? Why don't I let maybe even the idea that this could cycle back, I haven't played with this yet, to the LLM saying, oh, I was calling the non-recursive version, the iterative version of descend, and I got a different number of items than I was expecting to get. Can you think of what the problem might be? So the idea that by the time I'm engaged, the LLM has already thought about it and said, here are the 5 possible problems you might be having. Here are 10 possible problems you might be having where you're getting the wrong number of items. So this is my latest kind of crazy idea of like, why not compute as many interesting things about the expected value and the actual value, um, and and then at least feed that to the human, if not feeding that back to the LLM. So actually, I think that's a good time for me to pause. I'd love it if at least a few of you turned on video and we could talk a little bit about that. Michael, does this give you any ideas? Oh, Kent, great. You are muted, Kent.
Well, that's probably because I don't know that I have anything to say yet. I was just pondering it. I mean, in general, when you become really overly specific about something, there's a potential that you did like you didn't really mean it.
Okay.
Like I took a computational linguistics course once where it was just about human language, but this is like decades and decades ago, where the instructor, Bill Martin, said that anytime you make something concrete, you make it overly specific. And so you might not mean all of those things that you think that you're deriving automatically. Like some of those might just be chance occurrences, and I don't know whether they would all necessarily be things that you would want to check. Maybe you would.
Wait. I guess, maybe this may be, kind of about my style of debugging, where I've just spent time, kind of looking at things. Oh, even in fact, while debugging this very thing, I was thinking that the recursive version was getting it wrong.
Mhm.
In fact, it was the iterative version that was getting it wrong. Oh, and by the way, I used AI to help me in a very cheesy, simple way. I took the table, and I said, make me a mermaid diagram. This is like a dot diagram, it's like a textual representation of a diagram. It's cool. You can look up mermaid. Um, Kevin, I think who is it who someone is unmuting? It's well, everybody seems muted now. Um, so I made the diagram version of my test database, so that I could see, oh, okay, everything is connected to the top, to the root node, but not everything is a child of the engine block, right? Or the engine. So I was able to play around with it, but just using the AI to make a diagram for me, and then being able to look and say, okay, the problem isn't in the data. It did slightly misrepresent the diagram. It assumed there was a zero node. I can pull it up. It assumed there was a zero node when, in fact, what I was trying to say was that the zero here was just, maybe I should have used null, saying the car didn't have a parent. When it drew this, and I can pull it up, it drew it with a zero node, instead of starting with the one node. So I don't know whether people think I made a mistake or the diagrammer made a mistake, but the ChatGPT made a mistake. But so what I'm saying here is having something observe. Oh, you were expecting longs and you got floats. Oh, okay. Does that tip me off as to what I did wrong? Oh, you were expecting something longer or shorter where the average was different. Um, it doesn't, I don't think, even if there were 30 of these columns, especially if it were nicely laid out, it's like quickly telling me like what are the differences between what I'm expecting and what I got. I I don't see how that's gonna cause a I'm just trying to save myself time trying to figure out like what is like very often my test cases are the wrong thing. Like the code is doing the right thing and my calculation of what it's supposed to do is wrong. Um, but still knowing what the difference is and having something else kind of try to describe the difference, I don't see how that's going to get me into the problem you're talking about, Kent. What comes up for you?
Well, I mean, some of it is difference in test case test case writing philosophy, but I don't know if I was using this tool whether or not that would bias me towards one way or another. But I mean, some people write test cases that are quite specific so that they can get a test case failure when something changes, even if the something that changes is not a bug. And then other people write the test case more broadly because they don't want to get the test case failure when something changes that is not a bug. So those are just two different philosophies of writing test cases, and you're pressing on one of them in a certain way. Also, I just want to say it feels to me like there was a case in something, was it Llewellyn that did a earlier uh, talk on
Bella
test
Falco
or
did
something?
two of our meetings, and they're
And
just quick
he had it.
advertisement. They're on under Codeborging on YouTube, so you can still watch them. Back to you, Ken.
Yeah. I recommend going and doing that. I seem to recall that he had something where it was like iterating, trying to figure out the right test case or the right data or something, and doing it until it subsided and sort of was happy with its thing. And I don't know if it was to get around some problem where it was writing bad programs or if there was some other problem.
My
I don't
sense is that
remember what
it wrote a bug, and
yeah.
then he was able to get without the human having to do anything or having an API call. Yeah, it would iterate and I think in the first case he gave us, it stopped when it got to a point when it was going to use a library or something that it couldn't actually use and execute for itself.
Mhm.
Um, but I guess what I'm looking for here is something more where I have the execution environment here. I'm going to keep interacting with one or more LLMs in various ways. So anyway, one of the features I don't think I showed you folks yet And Michael, I'd love you get your input here. So the idea is I've written out all this data in a somewhat formal way. But it writes out this dedummy file for me. And the point of the dedummy file is to be able to do things like copy and paste something into ChatGPT, or in the case of Copilot, hit enter and let it try to write something for me. I figure nobody is going to expect to read, LLMs aren't going to automatically know how to read something like this, even though I like it because it's, clear how to execute it. But having it generate something that is much more the way a human would, and then uh, so and so this part of the point of something like this is to be able to quickly play around with, oh, how good is Codium? How good is, Copilot? How good is DeepSeek? To be able to, try out various things and see, are they capable of writing anything? Um, so Michael, senior Q programmer, um, I'm curious to get some of your thoughts. What kinds of features do you think would be interesting to add to something like this? Do you feel like commenting?
I think it'd be cool to have LLM that could like just tell you where your bugs are, or maybe give some more context on Q code. I
Right.
can
So
see
the
that being
idea
useful.
of feel free to turn on your camera if you like. It, the point is the closer to having it tell us where our bugs are, um, since Arthur's error messages are like so rich and I don't people who haven't programmed in KDBQ, one of the jokes that people sometimes makes is, the error messages have to be like a single character, like it's just like a tick, right? It's just like you're supposed to know what Arthur was thinking with these like very, very terse error messages that Arthur is famous for. The main builder of this system. But yeah, so one thing that is nice about things like Copilot, Michael, is I'm led to believe that it kind of knows what files you have been visiting, and it's making them available to the LLM. So that it has enough context so that if one were to turn around and say to it, here's the error that I'm making, the error I'm getting. I was expecting this value. I got this value instead. Note that this vector is longer than I was expecting. Note that it's, that there's some nulls in it. Note that whatever. So as much as possible, I think we could get some value out of the prompt engineering end of this. But yeah, I think yeah, debugging help would be super cool. What other things would you like to see in something of this ilk?
Is that for me?
Oh, I was hoping, but come to think of it, other people can chime in. But yeah, Michael, what other capabilities would you like to see?
I don't know that anything really comes to mind for me.
Are you a fan of Q for unit, or I mean, sorry, K for unit? Or what is there something you like better?
Uh, I don't know that I've used K for unit anywhere. Yeah, I don't know what I do for unit testing.
Okay, so other people, oh, I'm maybe this may have been confusing for people who are not already like big fans of vector programming and um, KDB. Um, Julius, do you want to say anything, ask anything? Okay, so let me show one other example. Um, in this case, I separated the code from the I put the test cases in their own file. And uh in part because because I it seemed in order to write these test cases well, I wanted to build up some data first. It may seem a little odd, but actually writing a stack in KDB is not incredibly obvious a piece of code. I had to work on it for a little bit. Um, but so in part because when you concatenate things in, you can lose a level of list, and so you have to be careful. Also, another problem, and Michael, you may have a better trick than this. In order to make sure that I didn't lose that the stack was a generalized list, I just stick a generic null in there to keep it from collapsing into a more specific a kind of collection, a more specific vector, which would cause me then when I want to stick something else in there that's not a number, then it stops working. So anyway, it'd be fun to get your point of view about that. This code is in that repository under examples. So you can comment on that if you feel like it. But so anyway, here I created a stack of just integers in it, and a stack with lists in it. Um, and uh, and then in the test cases, um, and given the way the framework is working right now, it's better to have the tests run on idempotent operators, because it might evaluate more than once, and then you're popping too many things off of the stack or adding too many things, and then you might think you have errors that you don't have. And oh, the link for the repository, yes. Um, I'll do that in one sec. So here, let's run. I think if I just come out and load again, and then run this example, we'll see that we get the two errors. Um, and those two errors are because um, in the definition of stack, I need to actually subtract one because of that very um, what's it called? That generic null. So now when I run this now it still tells me all the tests passed. Um, that's not a real bug that I fixed because of but in this recursion example, the earlier version of this, which didn't use scan, used over, really did fail to find every item. And so the test cases really did help me get this function right. Even if the stack example was it was artificial. I'm going to go look and get a hold of the link to the repository while but more questions, suggestions, ideas.
So what are you doing about, I thought I saw a timestamp go by in there. How is the timestamp not failing the thing, or what was going on with that?
Marvelous question. Let me get to that in just one second. Just want to make sure that I've got the code borging. So we've got a code borging um, repo, and now let me put this. Well, they've moved everything around in Zoom. It's quite intimidating. Okay, so there, I've now stuck the repo. Okay, so Q for unit, I'm sorry, K for unit, which is, I think, the most commonly used unit testing framework in this in the KDB/Q universe. It remembers what time it ran a particular test, and adds it to the output. So that's, I just didn't delete that column. I deleted almost every other column to make it and truncated the code so you could see errors quickly. But that the date there is just the date of execution according to the clock on whatever computer you ran it on. That make sense, Kent?
So the data is not part of the data that you're testing.
Right. That was just right, just an artifact of wanting to know, like if you fixed a bug and you saw, oh, well that was from yesterday. Yeah, I know I fixed that last night. Oh, okay. Yeah, that date is just there. So you don't, like, I guess, confuse yourself into thinking you're linking at something current that's actually old.
Mm. I'm used to doing a lot of testing that uses mocks, including mocking things like dates and random numbers and various other things like that. And I'm pondering like how I would tell uh, the LLM that I wanted to do that.
Well, funny you should say this, Kent, because Mike and other Q people can attest that a huge amount of what certainly in the literature about this language is all about. Yeah, so here's the repository you should be looking for. Is about like dummying up like stock market data and the right volumes of that kind of data, and so that you're in a position to test, if I represent it this way, what is the performance like? Yeah, so it's in fact, there's like lots of operators in this language for just like generating random stuff so that you can quickly do lots and lots of those kinds of experiments, often for performance tuning, because it's an environment basically for real-time data warehousing. And so yeah, that's but no, so you're saying what kinds of challenges would we face? Well, yeah, give me an example of a mocking up challenge, and let's think about that for a moment.
Well, I mean, a simple one is just something that sleeps for a little while and then wakes up and then asks what time it is or something like that. Um, and so, I mean, I usually use a coordinated set of sort of time utilities that knows about sleeping and that does things for predictable amounts of time and so on. So if I were to write the tests, they would be highly reproducible and there wouldn't be really a problem. But we're talking about having the LLM write the test. And I don't know how one would suggest to the LLM that it should do that in a way that is meaningful. Maybe you could tell it to read a bunch of.
Actually, funny that you should say that. That's not one of the things that I've experimented with yet. So let's add that to the list. That um describing at a high level to the LLM, oh, right, I am working in a language with these n different data types that mix and match in interesting ways. Make me, and I've got this stack thing. I want to make sure that I can push tables onto the stack, and I can push, kind of tables with lots of columns. And like, so think about all the weird combinations of things I might want to test and help me generate the test cases. and the test data. I didn't do that. Well, I might have had it help me generate some of the test data, but those test cases were ones I wrote by hand. But it's a good idea to have the LLM enhance your test cases or write them all. But you're saying how would it I mean,
Well, the thing I'm really worried about, I mean, there's a couple of things. I mean, like, in some ways you're just asking it to write a program and the program will have mocks in it and you just tell it to use them and presumably it goes and finds some examples of that kind of thing. But at the same time, it it seems to be like pathologically bad at stuff where it's using that as a constraint on some other thing where like the function operates a certain way in many of the examples it's seen, but it's going to operate a different way um, when it's mocked or something. And whether it can keep that straight or not, I don't know. I'm just kind of watching along here, and these are the questions that are running through my mind.
I think that is a really good thing. I almost got into the repository a tool that I'd love to get also suggestions about. Um, I'm writing a class about kind of running KDB on a supercomputer and what are the tricks that you need to use to benefit from having some ridiculously powerful machine. I happen to have access to a academic supercomputer, and I'm like, oh, cool. Let's see what you can do. And I found that doing one by one exploration of, how fast does X run? It was becoming uh, like a miserable amount of bookkeeping. And so the idea of being able to create a CSV file where you describe, well, here are all kinds of things I want to benchmark. And now you boot up, an AWS instance with a certain number of cores and a certain number of, drives and then set the S variable. There's a setting in KDB for how many threads or subprocesses you're allowed to that the system will go out and try to use. And so, run all these test cases where S is 0, and then run them all with S being equal to the number of cores that we actually have available. And there's a fun little framework that I'm using to help get that insight. Um, Michael, one thing's a little confusing to me. The manual disagrees with itself about whether you're allowed to reset S inside a running session. Do you happen to know um, whether that's one
No, did you find out
problem?
anything about that?
Pardon me?
Did you find out anything about that?
Well, let me see. I guess I'm in a good position to try it and see how it works. But I've just been restarting with dash S equal to a positive number. So I haven't actually tested which part of the manual is correct. Michael is used to using a machine with 92 cores on to recently to do his KDB programming. So anyway, that little system for um how to batch up a whole lot of benchmarky things and benchmark them all at the same time. I plan to push that out onto the Codeborging site also pretty soon. So people will be able to um comment on that. Um and Oh, and the codeborging@gmail.com is a good place to send your comments. CODEBORGING, codeborging at gmail.com. Please make sure you're in the meetup group and check out Codeborging on LinkedIn and elsewhere. Let's see. Is Q used for GPU programming? Aha. There is an example in the manual, and a friend of mine looked at it and said that it's actually a very kind of a reasonably intuitive example for calling out to CUDA from inside uh, uh, KDB. I've been doing studying of CUDA, but I haven't actually studied this example that they've got in the manual. They did it, what my friend was saying, without the shared memory concept. I guess that may be a higher performance option, but it's not, I don't think, as of right now, it's like that Q is making CUDA programming like wildly easier than it would be in another environment. It's just practical to use it, but I don't. I'll be learning more about it and including it, I hope, in the class on supercomputing and Q. Oh, welcome, Amy. Did you just show up?
Oh, yes. Yeah.
Hi.
Uh, I missed the start of the presentation.
You missed the earlier part?
I mean, I missed the beginning of this event. Yeah.
Well, it'll be on YouTube. It's did you already see? I can find the link. Um, and I'd love to get your thoughts. Let me put it into chat there, and the email address that I just mentioned, codeborging at gmail.com. Amy, do you know much about vector-oriented programming, as in APL and Q and stuff like that?
No, actually, this is the first time. So for me to actually start learning this. Yeah. Oops.
Yeah, it's a fairly obscure thing at this point. It used to be one of the dominant paradigms for mathematically oriented programming to take place in. And when I first met Kent, um, when he was uh, working at the MIT AI lab, he doesn't remember this because I was just one of many tourists who visited the MIT AI lab and got shown early Lisp machines and cool stuff by Kent. Whereas for me, this was like my visit to the MIT AI lab. So it's much more memorable to me than it is for Kent. Um, that At that point, you would walk into terminal rooms and there would be at least one machine with a special keyboard with Greek letters on it. That was a special terminal for use for this vector-oriented programming language um, um, developed um, for um, for mathematics. Anyway, okay. So folks, think about what kinds of talks you want to give about the intersection of AI and programming. And I just stuck that Codeborging email address in there. And please subscribe to the YouTube channel. And anything people want to say or talk about before we end the meeting? Okay. Thanks, folks.
Thank you.